The solar system was just beginning to form 3.8 billion years ago, and the planets were very different from what they are now. Intense geological activity, meteorite strikes, and atmospheric shifts were all part of the ongoing development and evolution of Earth, Mars, Venus, and other planets. The solar system was much less orderly than it is now during this time. The early sun produced enormous volumes of solar wind and radiation and was much hotter and brighter than the current sun. The atmospheres of the planets, which were still forming and undergoing evolution, were significantly impacted by this radiation and solar wind. Back then, Earth was very different from what it is now. The planet's surface was still cooling as a result of this. Volcanic activity predominated. A thick, steamy atmosphere that was abundant in carbon dioxide, nitrogen, and water vapor also surrounded the early Earth. Oceans had not yet formed, and comets and meteorites were continually pelting the planet's surface. Despite these challenging circumstances, tiny microbes were already beginning to emerge as life on Earth. Microbial life may have existed on Earth as early as 3.5 billion years ago, according to fossil evidence, and these organisms were able to endure in harsh conditions like hot springs and deep-sea vents. Mars, on the other hand, was also going through a lot of changes at this time. It had a thicker atmosphere that could hold on to heat, resulting in a more temperate temperature than it does presently. The existence of dried-up riverbeds, lakebeds, and mineral deposits that could only form in the presence of water provide proof that there was once liquid water on Mars during this time. It's plausible that Mars formerly possessed a worldwide ocean, which would have improved the planet's ability to support life. Yet over time, a number of causes led to the planet losing a significant portion of its atmosphere, including the loss of its magnetic field, which exposed it to the solar wind, and the cooling of its interior, which decreased volcanic activity. Venus was already a hostile planet. The planet's surface temperature reached as high as 900 degrees Fahrenheit due to the runaway greenhouse effect produced by its thick atmosphere, which was rich in sulfuric acid and carbon dioxide. As a result, the planet became too hot for any liquid water to exist, and lava flows and volcanic activity dominated its surface. There isn't much evidence to back up the hypothesis that Venus once supported life existence despite some scientists' suggestions to the contrary. The atmosphere of the planet is one of the most hostile environments in the solar system, and has probably been too thick and heated for liquid water to exist for billions of years. Mercury, the smallest planet in the solar system, was also very different. The planet was still undergoing a process of differentiation, where its dense metallic core was separating from its lighter silicate mantle and crust. This process led to a lot of geological activity, including volcanic eruptions and impact cratering. Mercury's surface was also bombarded by a large number of meteorites and comets, which left behind a significant number of impact craters. The planet's surface was also affected by the solar wind and radiation, which caused the planet's surface to be covered by a thin layer of regolith. Mercury's surface temperature varied widely, from extremely hot on the sun-facing side to extremely cold on the night side. While there is little evidence of liquid water on Mercury, some scientists have suggested that there may be ice in the planet's polar regions, where the sun never shines. The solar system's other planets and moons were also going through a lot of upheaval at this time. The frozen moons of the outer planets were still forming, while the gas giants Jupiter, Saturn, Uranus, and Neptune were still expanding and absorbing matter from the solar nebula. In conclusion, the planets were very different from what they are today. The planets were undergoing substantial alterations and evolution at this early stage of the solar system's development. Despite these challenging circumstances, simple bacteria were already forming on Earth, and other worlds like Mars were also thought to be potentially livable. We can better comprehend the universe by learning about the planet's evolution and the early solar system.